Take a look at problem 23-2. A particle charged plus 40 microcoulombs is located on the x-axis at the point x equal minus 20 centimeters, and a second particle charged minus 50 microcoulombs is placed on the x-axis at x equal plus 30 centimeters. What is the magnitude of the total electrostatic force on a third particle, minus 4 microcoulombs, placed at the origin? Well, let's make a picture of what this looks like. We have a first particle located at x equal minus 20, which would be a minus 0.2, at least on the x-axis. And that's a positive charge. Let's call that Q1. Then we have a second particle, minus 50 microcoulombs, located on the x-axis at plus 30 centimeters. That's going to be at 0.3 meters. And that's going to be a minus 50 microcoulombs, so that'll be our Q2. Then we have a third charge at the origin, also minus, and that charge, little q, is a minus 4 microcoulombs. So we have a attractive force between this charge and the positive charge to the left, and then we have a repulsive force from the two negative charges on the right. So there'll be two forces on this middle charge, and they both would be to the left. We want to find the magnitude of these two forces. Let's call them F1 and F12, and then add them together, and they will be in the left direction. Okay. So if we're looking at force F1, that's equal to K Q1 little q over the distance between them squared. K is 9 times 10 to the 9. Big Q is 40 microcoulombs, 40 times 10 to the minus 6. Little q is 4 microcoulombs, negative 4, but we've already accounted for the negative by the fact that we've figured out what direction the force should be. So we don't have to worry about keeping the minus sign in this formula at this point. And we are 0.2 meters away, so we have 0.2 meters squared. So what is this force? Let's figure it out. 9 times 10 to 9 times 40 microcoulombs times 4 microcoulombs divided by 0.2 squared. 36 newtons. And that force is to the left. Okay, the other force, F2, is going to be K Q2 times little q over the distance between them squared. That's going to be 9 times 10 to the 9 times 50 microcoulombs times 4 microcoulombs. And again, we don't have to keep the negative sign because we already know the direction of this force. And we are 0.3 meters away. I'm going to square that. So this is 9 times 10 to the 9 times 50 microcoulombs times 4 microcoulombs divided by 0.3 squared is 20 newtons. Also to the left. So we have this charge, this negative charge, little q, and we have these two forces. One is F1 is 36 newtons, F2 is 20 newtons, And so really our net force is going to be F1 plus F2, which will be 56 newtons. If I wrote this as a vector, our net force would be a negative 56I newtons, because it would be in that direction. So even by finding the magnitudes first, we can still come up with a final vector force, magnitude of 56 newtons.